The following video is about converting lines between polar and rectangular forms. Please remember the conversions that we learned in the last video. So we're going to use these relationships to convert the equations between the forms. So number one is in rectangular form, y equals -3. We're just going to see y is equal to r sine theta. So r sine theta equals -3. Now in this case, it's probably easier to think about it in rectangular form. Y equals -3 is pretty straightforward. You just graph the line y equals -3. But you have to be able to recognize it in its polar form as well. Number two, x equals -4. Again, you just replace x with r cosine theta, and x equals 4 is a vertical line. So we have r cosine theta equals 4. We see that pretty regularly. Now number three is in polar form, r equals -2 over cosine theta, or r cosine theta equals -2. Hopefully we recognize that from the previous problem. We see that that's x equals -2. So we graph x equals -2. Notice it's pretty easy to graph these things using the circles because each of the circles has a radius of something, and that shows you what your x value is. Now if we look at the first three, we want to think about what are these lines symmetric to, and their symmetry for y equals -3 is to the y-axis, and these two are symmetric to the x-axis. So if you fold it over this dotted line, you'd end up getting the symmetry. Now one more thing that we need to do is we need to declare what these things are called. So the x-axis in polar coordinates we call the polar axis, and the y-axis we call the line theta equals pi halves, which makes sense because if you draw the line theta equals pi halves, it just goes directly over this line. So polar axis and theta equals pi halves. So we also have to know what the symmetries of these things are. So the symmetry of any x equals or r cosine equals line is with the polar axis, and the symmetry of any y equals line or r sine theta line is with the y-axis or theta equals pi halves. Now number four, theta equals pi fourths. We're going to use this equation in order to get it in terms of y's and x's. So I replace theta with tangent inverse of y over x. Then I take the tangent of both sides. Tangent of pi fourths is 1. So we have y equals 1x, or y equals x. Now, as we graph the line y equals x, we realize that that's exactly on theta equals pi fourths. So it makes total sense that this would be theta equals pi fourths. Now where is the symmetry of this line? This is symmetric over a variety of different things. You can say it's symmetric over the line theta equals 3 pi fourths, or you could say that it is symmetric over the origin, because anytime you have 180-degree symmetry over a point, it's symmetric over that particular point. So typically what we're going to do is we're going to say that anything that goes through the origin is symmetric to the origin, or what we call in polar coordinates, the pole. Number 5, we see that we can just write r sine theta as y. So I have the line y equals 4, and the line y equals 4 is symmetric to the line theta equals pi halves, which we already learned up top. Number 6, I see theta equals 2 pi thirds. So I use theta equals arctangent of y over x and then solve for y. So I just do a little solving. I have to remember my unit circle. Then I realize that y equals negative root 3x. Now notice that this line is actually probably easier to draw using polar coordinates. That is not the red line that I need. So this one is actually easier to draw using polar coordinates because y equals negative root 3x. It's not exactly easy to go up root 3 to the left 1. So it's probably easier to just use the polar coordinates. And what we may notice is that this is symmetric to the pole. Number 7 and 8. So number 7, tangent of theta equals 2. It's actually probably easiest to just rewrite tangent of theta as y over x. So I see the line y equals 2x. So if I plot this, I go up to over 1, up to over 1. It's not exactly the easiest thing to graph, but it's close to pi thirds, just not quite. It's a little bit off. So again, this one is symmetric to the pole. X plus y equals 4 is a little bit more complicated. I mean, it's easy to graph in rectangular coordinates because you plot x equals 4 and y equals 4 using the standard form graphing by intercepts method. So you just cover up x, so 0, 4, and you cover up y, 4, 0. And those are 2 points, and you can graph any line as long as you have 2 points. So that's not too bad. The issue then is, how do I figure out what this is in polar coordinates? You replace x and y with r cosine theta and r sine theta. So you can either write it like this, or you can solve for r by factoring the r out and then dividing. So this is typically how you will see this line. Anytime you see a line that looks something like this, it will probably be symmetric to some sort of angle, and in this case, it is symmetric to theta equals pi fourths. You see how it's perpendicular to that line, and so you would end up with that being symmetric to theta equals pi fourths. 9 and 10 are very similar to number 8. So since this is in polar coordinates, we would multiply the cosine and the sine over. We distribute and turn this into x and y. And then if you want to solve for slope-intercept form, you can. You get y equals x minus 5. But you could also graph it from standard form if you wanted. So I get the point 5, 0. And I get the point 0, negative 5. In the interest of time, we'll just do the other one at the same time. So this one we multiply over, distribute, r cosine is x and r sine is y, and so we end up with 2x, y equals 2x minus 6. So that's actually going to be a little bit off the graph here. But I end up with these lines. I forgot to change it back to red. My fault. So we have these lines here. And what we want to do is we want to figure out what are they symmetric to. So in this case, number 9 is going to be symmetric to the line theta equals 3 pi fourths. Notice that it folds directly over that. This one is a little bit harder to see what its symmetry is because there's a y equals 2x type of relationship. And so it's a little bit harder. It's going to be symmetric with a line that has slope negative 1/2. Which is not as easy to draw. But it would be something like that, which is a lot harder for us to graph, so we don't actually memorize that one. So here are the 4 symmetries that we have to memorize. Hopefully you got enough practice seeing 10 problems there. But horizontal lines have the polar equation r sine theta equals a number, and they're symmetric to the y-axis, theta equals pi halves. Vertical lines are symmetric to the x-axis, the polar axis, and there r cosine theta equals a number. Lines that have theta equals some sort of radian angle or tangent theta equals some sort of number are symmetric to the pole. And then lines that have the equation r sine theta plus cosine theta, or y plus or minus x equals a number, they're symmetric to either theta equals pi fourths or 3 pi fourths. Now notice when you have a multiplier here like this, they're no longer symmetric to one of those two.